This is a funny type of question because it's not asking me to solve for x. It's asking me which of the following steps would I expect to get along the way to solving for x. So I'm going to go ahead and just solve for x, and then we'll have a little quick chat about which of these steps you saw along the way. I've got our procedure over here on the right. When you're dealing with a quadratic, there are several different methods you could use to solve it, but I think in this case, we're going to want to solve by what's called the square root method. Okay, and I'll tell you why the square root method is really ideal in this case. If you take a look at our equation over here, how many x's do you see in it? There's only one. It's an x squared, but there's only one letter x, which makes it ideal for this method. So what I'm going to do is, now that we have verified that there is only one letter x, I'm going to do what's called isolating the perfect square. I'm going to get the perfect square by itself, and let me just write the equation over here so we can, I'll have something to work on while I'm talking. Okay, so I have x plus 1 squared minus 6 plus 15. And the first thing I want to do to isolate the square to get it by itself is to add 6 to both sides. Those 6's are going to cross out now. And what I have left on the left side, what remains, is the x plus 1 squared, and on the right side this becomes 21. Now, step 2 has been completed. Next step is square root both sides. So you literally just square root both sides. That knocks out, right? Let me draw exactly what I'm doing here. I'm square rooting both sides like that. That has the effect of totally knocking out this exponent. It's gone. So now we have x plus 1 on the left side. On the right side, it's just square root 21. I'm leaving out one thing for the moment, but just make sure you've caught up with me to here. And if you need to, review one of those steps. But this is different than squaring both sides, right? This is the square root where you apply a radical. Now, we can talk about factor trees and so on, but I want to make sure we don't leave out this important thing. Everyone always forgets the poor little plus minus sign in front of the square root, right? That is a plus or minus square root 21. And what you do is you just stick that wherever the number is in the equation, right? If you're square rooting a number on the right side, that's where the plus or minus goes. It tends to not go on the side with the crossed out square. Okay, now the last step is isolating x. We're on our very last step here. And what I mean by that is we're going to subtract 1 from both sides. Okay, so on the left side, it's just x by itself. On the right side, it's plus or minus the square root of 21. And watch out where you put that minus 1. It can't go inside the square root, right? That's got like square root armor on it. It has to sit outside. So we have plus or minus square root 21 minus 1. And that would be my answer to this problem. Now, which of these steps did we see along the way? There are three major steps once you realize this is a square root method problem. There's isolating the perfect square, there's square rooting both sides, and there's isolating x. So see if you can reason to yourself why isolating the perfect square was not included anywhere over here. Do you notice how the isolation step was not in this mess? Right, I don't have any x plus 1 squareds in this, except for this thing that's inside a square root. That's clearly an error. So I think the version of this that's available, let's see, where is it? Is this right here. Okay, that's actually the very first option. X plus 1 equals plus or minus the square root of 21. It was that kind of third step of the problem or so. So in this problem, I would suggest just solve the whole thing and then go on the left and figure out which one of those steps you actually used.